For now, let me introduce at least myself. My name is Guus. I'm a master's student in the Netherlands. I study applied physics, and as a part of this master's degree, I'm doing an internship at Mogasang as an optics engineer. And today I will tell you more about the technology behind 3D printer and how it works, so you also know how your 3D object is printed in a correct way. And luckily Mustafa is here now. My name is Guus, and I'm going to tell you about the basic principles of the technology behind the 3D printing. The technology is called digital light processing, or DLP. And I'll tell more about that, what it is. So, as a starting point for this presentation, I assumed your knowledge as such. So, you have your STL file, a 3D model of someone's denture. You put it in a black box, which is the Dent 1, or any 3D printer, and the output of this black box is a 3D printed model. You might already have more knowledge on how 3D printing works, but this is my starting point, and at the end of this presentation, I hope that you will have more knowledge about it and have a white box instead of a black box. Yes. Let me start off with what is like the basic technology behind 3D printing, and that is photopolymerization. I don't know if you're familiar with it, but what happens with photopolymerization, basically we have long molecules, monomers, of atoms, and these free chains can move freely and they act as a liquid. By irradiating it with light on certain locations, you can these monomers will interact with each other, and they will create bonds between them and each other, and then it becomes a solid. So the 3D printing is based on the fact that you can control where the light will touch upon this material on the resin, and only in these regions the material will harden, or cure as it's called, and so from that you can make a 3D object from your model, and that's the basic idea. So if you don't want to know anything more about it, this was it, and then you can wait for the demo, but of course I'm going to tell you more about how the machine works and about its components. So the rest of the presentation is going to be, first I want to compare this technology, DLP, with another 3D printing technology, very briefly. And next I will explain the components that are present within the 3D printer. And finally I'll give you a short demo on how you can build your own 3D printed object within our software. And as we speak, there's also one being built right now. By the way, if you have any questions during the presentation, feel free to raise your hand and ask so everyone can follow me. I know you've been sitting here for quite a while. Don't worry, the break is coming soon. Yeah, so try to keep up. And if not, just ask me. Maybe I forget something. Like physicists always are known for the fact that we just are in a basement looking for particles and do not interact with the social real world. So I might forget something or oversee something, so feel free to interrupt me. So first of all, the DLP versus SLA. SLA is a laser-based 3D printing device, and DLP is, as I said, digital light processing 3D printer. And they have similarities, but they also have differences. So there are two similarities, which are, do I have a pointer? No, I don't think so, unfortunately. Oh, so on the outer two sides, we have the similarities between the SLA and the DLP, which is they both use a resin and they both are based on photopolymerization. And also, what they also have in common is that they make a 3D object by stacking 2D layers on top of each other. That are similarities. For the differences, the SLA uses a laser, and this laser scans over the surface area in such a way, and where the resin liquid has to be cured, has to be hardened, it will shine light on those locations and it will not shine light on the other locations. And so by scanning over the surface, one can make a pattern in 2D. These patterns of 2D images are stacked upon each other, and together they will form a 3D image.
So we have using a laser, we have to have chromophore. Okay, chromophore that reacts with the different type of laser, okay, and doesn't react to another type.
Yeah, so
that laser can react with this specific material, and it's called chromophore. So you have to use the specific material for that specific laser.
Yeah, so if I understand your question correctly, indeed the material of resin you're using is only reacts to certain types, certain wavelengths of light, and so you have to ensure you have a match between your laser and your material. Yes, yes. On the other hand, DLP uses a projected image, so it can scan the entire 2D plane at once, and it uses a mask. So you have a light source, you use a mask which creates the pattern, and this pattern is projected on the 2D surface, and in that way you can project your image as a whole, or your 2D image at once. I will explain this in further detail later on, but I mainly want to show you the differences between DLP and SLA and the pros and cons. So for the DLP, it's faster, 4 to 6 times. It's compatible with multiple resins because it uses a wider range of wavelength, so you can use multiple wavelengths for it, compared to a laser, which, as you mentioned, is monochromatic, so it usually only works for one type of resin. And finally, the DLP has a higher resolution in the low pricing area. On the other hand, the SLA, the design of the SLA printer itself is more compact than, for instance, the DLP you see here. The resolution of the SLA is constant over the entire surface, and this build area is bigger for a SLA than for a DLP. So now I want to continue to explain to you what the components are of a DLP printing device. Basically, it consists of these 4 elements. So first you have on the left-hand side for you guys the computer. The computer interacts with you, and the computer interacts with the machine itself, and it communicates with, so you tell it, I want this to be printed, and he tells the machine how to build it. Secondly, you have the light source, which is a lamp with an optical system consisting of lenses. Third, you have the digital mask. The digital mask creates the pattern for the image and determines the shape of your object. And finally, you have your resin tank, and in this resin tank your image will be created layer by layer. So how does the DLP printer works? So your computer, so let's say you have a 3D digital model and you want to make it a real model from it. So the computer takes this 3D model and slices it up in pieces, in 2D slices. So for instance, if you want to make this pyramid, the computer will slice it according to its resolution, and it will then print each slice after each other, and will stack them on top of each other, and these slices will connect to each other as well due to the photopolymerization. And as you can see in the third image, you will finally get a 3D printed object, like this image is made with an electronic microscope, so the dimensions of the width of this pyramid is about 500 micrometers, so that's half a millimeter. And you can see, you do not see the individual slices anymore, so it has a very high resolution. So this is the first part. You make from the 3D object, you make 2D slices. Then you go to the next part, that's the light source. The light source of the DLP has a wide range, so it can be applied to multiple types of resins, to multiple types of materials. and it must ensure that its intensity is high enough so you will get a solid and hard object. Then we go to the digital mask. Digital mask makes your pattern, and you can envision the digital mask as an array of many tiny mirrors, and these mirrors either will reflect the light towards the resin, and the resin will be cured, or it deflects light in another direction, and in those locations the resin will not cure. And so these mirrors altogether will make your pattern, your shape of this 2D slice, and will make your resin cure at the right positions. So for instance, if you want to make this model, then your layer 125, because you have these stacked layers, will look like this, and all on the white spots the resin will be cured, and on the black areas the resin will not cure. And for instance, on some other layer, this is the shape it will have, and so by stacking all these layers together you can make a 3D printed object. And finally, we go to the resin tank, and here the resin, the liquid resin is present, and slowly with the Z stage you can pull out your object, and one layer at a time. If you would pull up you would cure one layer, and then this layer is attached to the previous layer, but will also attach to the tank itself, to the bottom of the tank. This is not desirable, of course, because if then you would pull up your Z stage, you might crack your structure and it will fail. So instead of pulling up the Z stage, what you do, you move your tank in the X direction. So what happens, you have your model, and you have your stage or your tank here, and you pull your tank in the sideways direction, and by applying a force in this direction, you ensure that your model will stick to the Z stage, but not to your tank, and it will be completely, it will not break. And then you can slowly move it up for the next layer, and you can slide back your tank again, and you can get ready for your next layer. So in a minute, in the break, you can take a look at the machine, and you'll see that after every layer, the tank will move sideways, move back again, and then the next layer will be cured. So that was in very short the most important components of the DLP 3D printer of Mogosan, the Z1. And I hope that by this presentation you have a better feeling of what the idea is behind this technology, and that you have an idea of how it works, and that the black box you previously had is now converted to a white box, the Z1. So now it's time for the demo, and for the demo I'm just going to walk through the software with you guys and see, show you the functionalities of the software and the important features of it. So for that, I hope it will work. I can find it on this computer. Our software, and I'll guide you through it. So here you see your platform. In the top left corner, where you can upload a STL file, and if you open it, it will load. So here you see a denture. You can move around, look at it, and then back to its original position. So let's say we want to make this model. First of all, we have to flip it because you want, for the structure it needs some extra support, so it will not bend during the process. So what you want to do is you want to rotate it 90 degrees, 180 degrees. Yes, and what you also can do, you can move it around in the X direction or Y direction, Z. And in this way you can make your own perfect configuration. Then So what I wanted to add here is the support generation and also a platform underneath. So this platform ensures that your model will stay secure on your Z surface, and to connect your final model to this support, we're going to add supports. These are little pins that will attach the bottom plate to your model. This does the program does it automatically, so we're now waiting for it to generate these supports. As you can see, it now has all these supports, and it will completely build this image. So next thing you can do is you can create the slices, the 2D slices. And here in the right top corner you see the estimated build time is now half an hour. We could reduce that by lowering the object and making small supports, but for now we'll keep it in this way. Then we can move to the slice view, and here you can see each slice. So we start with one, which is the platform, and then you see a lot of supports. Very good. And then you slowly see your denture created in every stage. So this is the 3D slice view, and so if your computer is connected to the 3D printer, you can press play, and then it will automatically start creating your device. So that's like in a nutshell how this works, and I believe after the break we'll have a workshop also and learn more how you can play around yourself with the functionalities of this software. So yeah, for me that was all I wanted to tell you guys. I hope you understood everything. I'm happy to invite you to the machine in the back during the break to see how it works and ask further questions. And if there are any questions now, feel free to ask.
Any questions?
No? Thank you for your attention.